Did you know that the average rocket can travel at speeds of over 17,500 miles per hour? That's fast enough to escape Earth's gravity. Crazy, right? Today, we're going to dive into the world of rockets and explore how they work using Newton's laws of motion, all while launching our very own LPG rocket. Hey everyone! Welcome back to the channel. Today, we're going to take a look at Newton's laws of motion and how they relate to our super cool LPG rocket experiment. If you've ever wondered how rockets defy gravity or how they soar into the sky, you're in the right place. Newton's laws are all about understanding motion and forces, and by the end of this video, you'll not only grasp these concepts but also see them in action as our rocket blasts off. So, let's get started. Presentation of problem/challenge. Now, let's talk about the challenge of understanding motion. It can be pretty tricky to wrap your head around how forces act on objects, especially when we're talking about something as complex as rocketry. You see, when a rocket is launched, there are several forces at play. Gravity is constantly trying to pull it back down, while the thrust produced by the rocket's engines is trying to push it up into the atmosphere. Understanding how these forces interact is crucial for anyone interested in space travel. Without a solid grasp of these concepts, it would be impossible to design and launch rockets successfully. We need to comprehend how Newton's laws can help us predict the motion of these rockets, which brings us to our next point, exploring these laws in detail. Exploration/development. So, let's break down Newton's laws of motion. The first law, often called the law of inertia, tells us that an object in motion stays in motion and an object at rest stays at rest unless acted upon by a net external force. This is super important for our rocket because it means once it's in motion, it will continue to travel until gravity or air resistance acts on it. Next up is Newton's second law, which states that force equals mass times acceleration, F equals ma. This means that the heavier the rocket, the more force we need to apply to get it moving. This law helps us understand how much fuel we'll need to launch our LPG rocket effectively. Then we have the third law, which is all about action and reaction. For every action, there's an equal and opposite reaction. When our rocket expels gas downwards, it pushes the rocket upwards. This is the fundamental principle behind rocket propulsion. So, as we blow up our rocket with LPG, we're creating a reaction that will launch it skyward. Now that we understand Newton's laws, let's see them in action with our LPG rocket experiment. Climax/key moment. Alright, the moment we've all been waiting for. It's time to launch our LPG rocket. As I prepare for the launch, remember everything we just discussed about Newton's laws. When I ignite the LPG, you'll see the gases shoot out of the back, and that's when our rocket will take off. Here we go. Ignition sound, and boom! Look at that. The rocket is soaring into the sky. You can see Newton's laws in action right there. The force of the gas escaping creates an upward thrust, overcoming gravity and sending our rocket into the air. It's absolutely exhilarating. Conclusion/summary. Wow! What an incredible launch! Today, we explored Newton's laws of motion and saw how they apply to rocketry. We covered the law of inertia, the relationship between force, mass, and acceleration, and the action-reaction principle. All of these concepts came together to help our LPG rocket achieve liftoff. Understanding these laws is crucial not just for rockets, but for all kinds of motion we encounter in our everyday lives. Call to action, CTA. Thanks for hanging out with me today. I hope you enjoyed the experiment as much as I did. If you have any thoughts or questions about Newton's laws or rocketry, drop a comment below. And don't forget to check out my other science-related videos for more awesome experiments. Hit that like button, subscribe if you haven't already, and let's keep exploring the wonders of science together. Catch you in the next video.